Hi everyone. Today I was working with the MNIST dataset of handwritten digits recognizer model using deep learning. So I'll be showcasing that. So let us quickly get started. Okay, so the first thing is we import the necessary libraries. So these are pandas, NumPy, TensorFlow, Keras, Matplotlib for some visualization, and Pickle to save the model. So this MNIST dataset is pre-installed in the Keras module. So I'm just calling this MNIST model, and train test data is already separated. So if you look at the length of the X-train, the train data, there are 60,000 handwritten digits on which our model will be trained. So if you look at the shape, it is 60,000 into 28 into 28. That means that each handwritten digit is an image of 28 cross 28 pixels, and each pixel will have some values. So Y train is also 60,000, simple. And we have separated 10,000 more data for validation for testing purposes in next test. So now let us see how a single handwritten digit looks like. So if you look at plt.matso, I'm looking at the ninth entry of the train dataset. Here we can see this is a one. And as this is a 28 cross 28 matrix, so some values will be all the pixels, the values will be between 0 to 255. So generally the model performs better if you scale the data. So I'm scaling as the highest value is 255 and the lowest value is 0. So I'm just using a very simple method of min max scaler. So x train is equal to x train divided by 255 and x test is equal to x test divided by 255. So after that, as this is a 2 cross 2 value, right? So like the first column, like the fifth row and fifth column, there will be some values. So first we need to flatten it so that we can make it into array. So 28 from 28 matrix, we can flatten it into 784 features because 28 into 28 is 784. So x test flattened is equal to x train dot reshape. I am reshaping it with length of the x train and 28 into 28. Simple. And similarly, I'm doing this for the x test as well. So now if we look at the x train, the flattened one, the save is 60,000 comma 784. Okay, so if you look at a single value, a single entry from the flattened data set, extend flatten, I'm looking at the second entry. So this is how the data look like. I've already scaled it, and also I've also made it, I have flattened it as well. Okay, so there are a lot of zeros and there are some values. Okay, so now we'll use the Keras module to create a very simple neural network, right, with no hidden network, with no hidden layers, and I believe I will be using the sigmoid activation function as the final activation function, and optimize using the Adam optimizer. So which is adaptive moment optimizer. So after that, I'll be calculating the loss using the sparse categorical cross entropy, and the metric that I'll be looking at is accuracy with 5 epochs. So there will be 5 forward and backward propagations. So model is equal to Keras dot, I am doing a sequential. So Keras dot layers. So as there are 10 digits, so from 0 to 9 there are 10 outputs that we require. So I am giving 10 outputs, and the input dimension, as we've discussed earlier, there are 784, and I'm using the sigmoid function. While combining, I'm giving the optimizer as atom, loss is sparse categorical cross entropy, and metric I'll be looking for is accuracy. So when I fit the model, we can see the accuracy is around 0.9264. Okay, which is pretty good. So when we plot the model, we can see, as I have created the deep learning model with no hidden layers. So I am giving the input of 784 features, and I am getting 10 features as the result. So when we evaluate the model for the test data set, we can see I am getting an accuracy of around 91%. Okay, so when we predict the data set, we see that ypred is equal to model dot predict x is flattened. So this is how a single entry of the prediction look like. So we might be wondering which value, like is this a 1, 2, 3, or 4, or what? So if we look, what is the actual value? Y test 0 of the first entry is 7. So of all these values in the prediction, right? because we are using this sigmoid activation function at the end, there will be some percentages for all the 10 outputs that I am looking at. So the maximum of it is the actual prediction. So if we use np.argmax, which will give the maximum value, right, of ypred 0, we'll see that it is 7. Simple, very easy. So I'm giving this as my prediction, so which I'll be checking with y-test. So ypred labels is equal to np.argmax I for I in ypred. So I'm used list comprehension to gather all the predictions. So then I used I wanted to plot a confusion matrix. So here we have the confusion matrix. So when we look at the confusion matrix, we can see some peculiarity here, right? Which is pretty obvious. So when we write the digits, obviously some fives are equated as 3. So there are a lot of there are around 46 numbers this is that are misinterpreted. So the actual value was 5, but it was interpreted as 3. Simple. If you look at any more such high values, so here we have 2 and 3. So 2 and 3 has also a curve on the top. So our model is failing 37 times to predict the 2, and it instead it is predicting it as 3. Similarly, we have a 43 here, so 2 and 8. So there is some confusion between 2 and 8 as well. Okay, so pretty good for without any hidden layers. So now we'll be using a single hidden layer, and there will be 100 hidden neurons. So first, I'll make a sequential model. So let me name it model 1. So Keras dot layers dot dense. So the input shape is 784 because there are 784 features, and I am using the ReLU activation function in the hidden layer. And there are 100 neurons. And for the final layer, obviously, because I'm using I'm finding 0 or 9, I can either use activation function as sigmoid or softmax. So I'm going with sigmoid here. So there are 10 neurons. There are in the output layer there are 10 neurons. So if I compile using the Adam optimizer sparse categorical cross entropy and accuracy, I've kept the epochs as same 5 as the previous time. We can see we are getting a train accuracy of 98.5%, which is a very great improvement from the previous model. After that, if you use the plot the model, so here we have three values, right? So here you can see the input dimension is 784, and I'm getting the output of 100 features, which are then fed to the hidden layer, and hidden layer gives us takes 100 features and gives us 10 values. So when we evaluate for the X test, we see that the accuracy is 97%, which is very good. So when we look at the predictions here, so here also we'll use the NP argmax to find the prediction. So here y pred1 labels will be 7. So here if we do the confusion matrix, so the number of misinterpreted values have become very less, which is pretty obvious because we have increased the accuracy. Okay, so as model 1 is performed better, I'll be saving the model. So thank you. Okay, thank you very much.